Hi, I'm Everett and welcome back to the shop. This time we have another one of those projects for a buddy who's got a buddy who's in a bit of a pickle. I got a timing cover off of a front end of a 5.9 liter Cummins diesel engine out of a Dodge pickup. And what had happened is the high pressure fuel pump, the CP3 fuel pump, came loose. It broke off a couple of the studs, hammered around in the hole, and generally made a mess of it. It gives me a chance to try out some new tools I've got and try to make do with what I have, because there are some things that I don't have. So anyway, hope you find it interesting. This pump here, for whatever reason, the nuts came loose or something, whatever, but it rattled loose and it banged up the journal on the front of the pump, as well as the bore inside the front timing case. He's already got a line on a good used pump that'll, so we can get that back in business. This part here is give or take $800 to $900 Canadian to get, and buddy doesn't have a whole pile of cash. So, so my friend or my buddy asked me if I could do something with this. What I intend to do with this is bore this out and sleeve it. We'd originally thought about maybe building it up with weld and then machining it out, but part of the issue with that is trying to find a location center on it. So I think what we're going to do is we're going to sleeve this. And as well, we need to face this top here, probably take about 5 to 10 thousandths off of it to clean it up again. Partly due to the fact that you can see the shiny spot here. Well, that's raised up from the worn part here from when it was vibrating. We've also got to pull this stud, and we're going to Healy coil all 3 holes just to make sure. So this is this is going to be a bit of a repair. I'll put a couple close-up pictures of what the bore looks like inside here. You can see that ridge there, that worn area, it's about 13, 14 thousandths off, so it's actually egg-shaped by about 13, 14 thousandths. As well, the bore, the snout of the fuel injection pump, it's been banged up a bit. It's supposed to be a nominal 50 millimeters. It's actually quite a number of thousandths lower or smaller than that, so it's not going to fit in properly anymore either. So yeah, we're going to try to fix this up for this guy. These 2 holes here, the studs are out of them. I mean, the threads don't look that bad visually, but still, we're going to coil them later anyway. We're going to have to coil this one definitely, and this is the one with the broken stud in it. It's sub-flush, of course. So what we're going to do is, I have a 1/4 inch, well, my little center point that I use for finding the center of center punch marks. I'm just going to use it to eyeball the center of that hole, which is going to have to be close enough, because we're going to try to remove that stud. That should do it. We'll lock both axes on the tables. 1/4 inch cullets out, 3/8 cullets in. I would have preferred a 4-flute center cutting end mill, but all I've got is a 2 in 1/4 inch. It's got a 3/8 shank. Spin the spindle about 440 RPM. All I want to do is make a flat spot in there so I can get a center drill point in it. Excellent, we're down to clean metal on that broken stud. Now that that's there, I can use a letter D drill, which is pretty close to 1/4 inch. Except if you notice, the flutes on this one are left-handed. So this is where the reverse we added not that long ago is going to come in handy. Nope, she's going to fight me the entire way, isn't it? On the bright side, it looks pretty close to center, but as I said, kind of hope to peel it out. Well, that's through the stud. She's pretty much bang on center. Now, as far as finding center on the hole, at the very bottom, there's a spot that's, 16th or so, or maybe millimeter and a half, whatever. Now about a millimeter, a little over 16th, that wasn't actually damaged. And that's where I have the little stylus or probe of the dial test indicator. I have the tension off the belt here so that I can turn just turn the quill nice and smoothly. Now, I know you're not going to be able to see it in the screen there, but you're just going to have to believe me here. Please just trust me. It says like 11 and a half there, and it'll bounce up to 12 as far as the actual needle reading on the dial. Yeah, bouncing up to 12 there-ish, almost 12, 11 and a half. So after, adjusting it and the table's locked down, we're within about a half a thousandths of the concentricity, or within concentricity of a half a thousandths of the undamaged portion of the bore. Table's locked, that's about as good as we're going to get. So you can take this out. Maiden voyage of the new toy. There we are. This is what I did with this high-speed steel tool. I basically, made it into a tooth flute, ground off the tooth flutes there. It was messed up to begin with, so I don't feel bad doing it. And it was a cheap one that came in a package straight from the Far East there. I put a little bit of a nose radius onto the corner there. The edge is still nice and sharp. So let's see how this works as far as tool geometry. And we'll go into the far end piece, your end part here. I don't have much for half-inch boring tooling because this is the first half-inch shank boring head I've had. That's not bad. I don't mind that. So, yeah, there we go. Although, that's kind of hard to grab. I might slow it down just a hair. I don't mind slowing it down a little bit. Let's go down to almost 300, it'll be 285. Good, okay, so now, perfect, okay. There, I like that. Getting close? Yeah, we're getting close to the edge. Now our parallel here is 188 thousandths, so roughly 3/16. What we're going to do is we'll set this on there, 0, bring it up, slowly bring this down to 188 thousandths. There. Now I realize that taking a measurement from another measurement to another measurement induces errors. The thousandth or so that will be off here is not going to matter if there is error. What we're doing is we're just boring down to the point where we can put a sleeve in. That I want to leave the portion that was undamaged in place, so we'll have probably about a millimeter and a half, whatever, a couple or a 32nd or so of bore that remains from the original machine or original hole. That's what we're going to press our sleeve against, and that also will get us just past where the O-ring has to seal. How much we open it up is arbitrary. I'm thinking a couple millimeters worth, so-ish. So I mean, we're going to make a new sleeve, glue it in, and then machine it to the size we need, so it's not a big deal. But yeah, we'll just go from here. So let's back it up a bit. Now this little dial here, I've noticed, doesn't really grab very stiffly as far as, yeah, oh, wrong way, this way. One, two, three, should be starting to take a cut. Actually, that's cutting quite nicely. I'm going to bring you in a little closer so you can see this. This is good. All right, let's try this again. Alright. A little bit of tension on Actually, that modified milling cutter is doing a nice job. Now, as I say, we're not going to go all the way through. That last little bit that we could use as a register is going to stay there. Okay, so yeah, right on. Nice and smooth. I mean, apart from the little ridges where I corkscrewed back out. And I'm going to go down to where my readout says 730. That leaves, yeah, you can probably see it there, that leaves that little lip in the back. I'm going to double check there as far as depth with that. I'm going to double check with that depth as far as our O-ring. So yeah, I just double checked, and that's going to be enough clearance so that the O-ring itself will still seal onto the new sleeve that's going in. .4.1. Good enough. That's what we'll use. So now that we have our ledge in the bottom there against which we can press up our sleeve, we need to make the sleeve. I took a snap gauge reading off of the hole that we bored out. It's 2-inch 129 thousandths. Well, 2-inch 128, 2-inch 129. Using a snap gauge, that's about as close as I can get with that. So what we'll do is we'll shoot for our sleeve to be made 2-inch 128, because that will allow us to use the bearing retainer or sleeve retainer to hold it in place. Yeah, this is 2.5-inch material. So we're going to have to take off what? Yeah, 370 some. All right. Two-inch 128.5. Yeah, I'll go with that one. All right, I gotta go deal with little man. Well, it's a few hours later here, and now that little man's, well, been changed twice as far as his diapers are concerned, and we've been to the park and for a walk and had supper and dessert, and he's all tucked in bed now, and well, yeah, he went to bed quite happily, and he's now pretty much out. I watched him in the monitor. I mean, I know that sometimes I make a comment of, oh, well, gotta go, but, you know, for what it's worth, please don't take or get me wrong. I by no means am complaining. I'm very thankful for the little guy, and so I just don't want to give the wrong impression to anybody. However, a few hours later, and piece is allowed to cool a little bit, and yeah, I'm glad I didn't go any further, because, I mean, it'll still be fine, it'll still work. However, we are at about, well, basically letting it sit for a couple hours. We went from 1-inch 128 down to about 127 and what is that? 4/10. So I mean, it will still have roughly a thou and a half clearance to slide it in the bore. So that makes me happy. Now, what we need to do is drill and then bore the center out. The final bore in this thing is going to be 50 millimeters, not, so I mean, I don't want to go that far. Probably take it about 48, 49-ish, somewhere in that neighborhood. Then part it off and slide this in with some bearing retainer into the bore on the cover. 47.8. I think we'll go there. So take, there we go. Just take the burr off so I won't cut myself. So this measurement isn't super critical as long as I have at least 3/4 of an inch to work with, because it'll be 730 thousandths. So there. If I cut that and just take the line with it, then we should be pretty much where we need to be. I've already set the tool to square to the chuck. There we go, we'll call that where we need to be. Lock the carriage. Turn this down. And here's hoping this doesn't come apart in nasty ways that we don't want. Why are you... There we go. Sweet. All right. And the rest of this is still usable as scrap later. That's a bit warm. The ring in the inside here is not a big deal. That'll come off in the when we start machining. This is actually over length anyway, so right on. I'm happy with that. Well, after looking through the catalog of Loctite products and the myriad different things they have, I decided to settle on, well, Permatex 62040, which is basically the same as Loctite 640. It's what I could get, and my local parts shop had it, parts store. So I really like the guys at Parts Stop. They're really good. What I'll do is put a little bit in there. Have a piece of welding rod here, 16th inch stainless welding rod that I have left over from another job. Wipe that around. And then, yeah, start adding some to the outside here. Try not to get too much oil or anything on it. That's the side that goes down. Now the thing is, I know this has to sit and do its thing for a while to cure. I've already done one slip test fit, and it does just slide down nicely. So definitely be less than the 7 thousandths gap that is the maximum for this this particular product. Come on. Spin it up a little bit. There we go. Now we just have to sit and wait. Now, I know there are going to be a number of people who comment on the fact that, no, you shouldn't be using Loctite on aluminum. Believe me, I spent a few hours researching Loctite and looking through their different sites and their different pages, and I found the one where they were talking about active versus inactive metals. And according to them, apparently commercial aluminum, not pure aluminum, but commercial aluminum that's been alloyed with various other things, like 6061, which is what this sleeve is made from, have enough copper and other things in them to consider them an active metal. So now all I have to do is we'll just let this thing sit and come back to it later. I got the boring head back in, I got the tool in. We're going to start boring it out, and then we'll get it out to pretty much our finished size, then we'll deal with the surface here. You know what's a good sign? That little bit of cast at the bottom just peeked through. I think we got her. So there we go with that. Yeah, that little, the spot on the bottom where I left the cast in place so that it could have a shoulder to move up against, just poked through. So I like that. All right, next step is we're going to need to clean off this outside surface. Now we're going to get into the facing. This is part of the reason why I wanted this head. Bring it out just a smidge. Where it's cutting. Yeah, see? There we go. Retract it. We'll take another cut. Yeah. Taking another couple thou. See, another 4 thou or so, 4 or 5 thou. There we are. It's pretty much flush. I don't know about you all, but I'm actually pretty tickled with this little unit. Again, apart from this dial here that seems a little floppy, I got to figure out what to do with that at some point. But other than that, I'm pretty happy with it. And the best part was, unlike the NAR-X's or even the Chandler duplexes, sometimes when they come along, I could actually afford this one. Now the chamfer on the edge, we're going to make using this. It's a, well, basically somebody modified a center drill. It's a 1/2 inch shank. I think it's a modified center drill, a countersink or something. Anyway, it's got an 82 degree chamfer on the end. I know I'm looking more for a 45, but this will be close. This will be close enough. It's just enough to get the O-ring in is what you need. I may have to come out just a little bit more. All right, that will do it for our chamfer. Now, I'm just going to go down till it's just touching. They're just touching. Zero that. This is just within the work scope of this machine, the work envelope. So, say it was about 5 or 4 thou off. Let's just take 6. Nice. Love it when a plan comes together. Again, the high pressure bump being 15 thousandths more into the case is not going to matter at all, because they're straight cut gears. There we are. Right on. All I have to do is put coils in these 3 holes, and this thing's out the door. He wanted something longer, so thankfully I do have some longer length inserts. These are M8s. And I probably could go a little faster, but I don't really need to. Eight, 9. Okay, let's go 950, just to make sure that we have lots of clearance. Now we'll pull the tension off the belt. Grab our drill chuck tap handle. Sometimes easier just to spin them back out with a tap wrench. There we are. Now we can take our coil, make sure it stays on the tool, spin it in the hole. And I can hear little man start to squeak, and I can see him start to move in the monitor there. So, I don't know if you can hear him. Yeah. Oh, poor little man. Life's so rough when you're 2. There we go. I'm happy with that coiling. Take our little pin tool and pop. There's our little tab on the bottom. So now, theoretically, we should have a nice little M8 by 1.25 thread. So anyway, you've seen me do one. I'll do the other 2 off camera after I deal with little man, and then yeah, I think we're pretty much done with this job. Anyway, yeah, thanks for watching. Thanks for subscribing. Appreciate all the support and all the likes and comments that people have given. If you haven't subscribed, that's cool. Thanks for coming to spend time in my shop with me. I'm just happy that you found this, interesting enough to click on it. So if you do want to subscribe, that's cool. If not, no big deal. Anyway, thanks again, everybody, and we'll see you next time.